Good morning, Mr. Lee. It's a pleasure to have you here. I hope your trip went smoothly.
Good morning, Anna. Yes, thank you. The flight was on time and the hotel was excellent. I appreciate your team arranging the transfer.
Of course, we always make sure our guests are well taken care of. Now, I understand you are here to evaluate our new soldering solution for your surface mount assembly lines.
That's right. We're looking to replace some of our older units with more precise and energy-efficient models. I'm particularly interested in performance under high-volume workloads.
Excellent. Then I think you'll be quite impressed with our latest unit, the SX800 series. It's engineered specifically for high-precision soldering tasks in demanding electronics production environments. This demo will walk you through its core features, performance metrics, and some test use cases.
Perfect. I'm keen to see the data, but I'd also like to observe how it operates in a real-time setting. We're looking for both technical performance and operator usability.
Absolutely. We've set up a working unit on the floor with a live feed, so you can see every step. But let's begin with the technical overview. The SX800 features dual-zone heating with independent sensor feedback, which ensures temperature stability within plus or minus 1.8 degrees centigrade, even during continuous operation.
Interesting. One concern we've had with previous units is overshooting during reflow. Does this one mitigate that?
Good question. We use a predictive control algorithm. It's adaptive, meaning it learns from thermal patterns during operation. When combined with our platinum temperature sensors, this nearly eliminates overshoot, especially during delicate SMD soldering.
And how quickly does it recover between joints? We deal with dense board layouts and minimal time between contact points.
The recovery time is under 0.5 seconds, significantly faster than the industry average of 1.2 seconds. That's partly due to our microceramic heating element, which responds almost instantaneously to temperature shifts.
That sounds promising. What about energy consumption? We're under pressure to reduce power draw across all lines.
Understood. The SX800 consumes 32% less power than our previous model, and up to 40% less than standard systems from other vendors in similar performance classes. It enters low power standby automatically between cycles, if idle for more than 6 seconds. This feature alone reduced average daily consumption by 11% in pilot testing.
That's impressive. Now, how is this unit controlled? Our operators vary in language and technical ability. Interface usability is key.
It's a 7-inch capacitive touchscreen interface with multilingual support, including English, Chinese, Spanish, and Vietnamese. You can also connect it to our remote monitoring system via Ethernet or Wi-Fi, and it's compatible with factory MES platforms.
So it supports data logging.
Yes, and more. It logs real-time data on temperature, cycle duration, error codes, and operator actions. All logs are exportable in CSV or JSON formats, and the unit supports OTA firmware updates via secure connection.
Let's talk durability. These tools are heavily used 3 shifts a day, 7 days a week.
These units are rated for continuous industrial use. Internal stress testing simulates 5 years of non-stop operation. The heating element lasts up to 40,000 cycles, and the handpiece is IP54 rated for dust and limited moisture exposure.
And the ESD protection?
Built in, the tip and ground are isolated with 1 megohm resistance, ensuring full safe operation. We also have an optional grounding monitor module you can integrate into your benches.
Can I ask about operator fatigue? Some of our team complain about hand strain with heavier units.
Absolutely. The new handpiece weighs only 82 grams, compared to 120 grams in most competing models. We redesigned the grip with a softer polymer and improved balance, so pressure on the wrist is reduced by 27% according to our ergonomics study.
Okay, that's a big improvement. Could we do a live demonstration next?
Certainly. Let's move to the test bench. This is a multi-layer PCB from a typical telecom module. I'll demonstrate a series of SMD connections, reworks, and micro-joint repairs.
I'm watching closely. I'm particularly interested in how stable the temperature is during rapid switching between joints.
You'll notice I'm switching between fine and medium tips. The system recalibrates instantly. The heating response you see is linear and controlled, there's no spike or lag.
Yes, I see that. And I assume this demo unit has the standard calibration?
Correct, we haven't made any enhancements. What you see here is production spec. Now, if you look at the on-screen graph, the blue line shows tip temperature, and the green is internal heater temperature. Both remain within spec limits throughout.
That's excellent. What's the warranty coverage?
Two years standard on the unit, and 1 year on consumables like tips and filters. We offer optional on-site service contracts as well, and spare parts are available globally.
How do you handle large-scale deployment? We'd be looking at 120 plus units if we roll this out across 3 locations.
We handle bulk deployments regularly. We assign a project engineer to assist with rollout logistics, operator training, and system integration. Units are serialized and tagged for asset tracking, and we can preload your preferred language and settings before shipping.
What about certifications? We require full RoW HS and CE compliance for all equipment.
Of course. The SX800 is certified RoW HS3, CE, and FCC Class A. We also hold ISO 9001 and 14001 certifications for manufacturing and environmental processes.
Very good. And just out of curiosity, how does this compare to the TechCore ST500 series?
Good comparison. We've benchmarked both units. The SX800 outperforms the ST500 in recovery time, power consumption, and thermal accuracy. It also has a better user interface and faster startup time. Plus, our model is priced about 12% lower in volume orders.
That's compelling. I'll need to review this internally, but I'd like to request a pilot unit for one of our Shenzhen lines.
We can ship a demo unit by Friday. Our support engineer in Shenzhen can assist with the initial setup and collect performance data.
Great. Can you also send me the technical datasheet and the operator training manual?
Absolutely, I'll email them to you this afternoon, along with test reports and benchmarking documents. Do you have any other questions I can help with today?
No, I think you've covered everything. I'm very impressed by the depth of information and the professionalism of your demo.
Thank you, Mr. Lee. We truly appreciate your interest. I look forward to working with your team further.
Likewise. Let's stay in touch.
Good afternoon, Anna. I appreciate you taking the time for this call. We've got some issues on our side and I'd like to address them promptly.
Good afternoon, Mr. Sato. Of course, I received your email and immediately reviewed the batch report. I'm ready to discuss the situation and propose some solutions.
Great. To give you the full picture, on July 1st, we received a shipment of 1,200 units of Model X J504 touch controllers. Our quality control team conducted a spot check of 300 units. Unfortunately, we identified defective units. About 28 controllers had non-responsive touchscreens and abnormal boot sequences.
I see. That translates to around a 9% defect rate in the sample. Definitely higher than our standard acceptable quality limit, AQL, of 0.65%. That is concerning. I'd like to sincerely apologize for this issue. It's not in line with our quality standards.
We understand that no system is perfect, but this particular batch was meant for a fast-track order to a medical device client. Time is very tight, and the defective rate has impacted our production schedule.
I completely understand the urgency and the downstream effects this may cause. I want to assure you that we're already conducting a root cause analysis, RCA, to determine what went wrong. Early indications suggest it could be related to a calibration inconsistency at the final assembly line.
We suspected that. Our engineers observed that the faulty units all shared the same firmware version, so perhaps something went wrong during the update process?
That's very helpful information, thank you. Yes, we did implement a firmware patch in the last production cycle to address a known bug in the voltage regulation module. It's possible that the update script didn't execute properly on some units. We'll need to verify that.
I see. So what are the next steps? As I said, we're on a tight delivery timeline. Any delays will affect our customer commitment.
I understand. Let's talk about short-term containment and long-term corrective actions. First, for the 28 defective units, we can immediately dispatch replacements. I can expedite a replacement shipment of 35 units to cover any further findings. Would that work?
That would help. How soon can they arrive?
If we prioritize the order and ship via DHL Express, you'll receive the package in 3 to 4 business days.
That's acceptable. But we also have a concern about the cost. We've lost valuable time, had to stop our SMT line, and reassign labor to troubleshooting. Can we discuss compensation?
Certainly. Given the impact on your operations, I propose 2 options. Option A: we offer a 15% discount on the total invoice for the affected batch. Option B: we issue a credit note equivalent to the value of 60 units, which can be applied to your next order.
That's a reasonable offer. I'll need to check with our finance department, but I'm leaning toward option A for immediate cost relief. What about the labor time spent by our technicians?
We can cover up to 10 man-hours of technical rework costs if you provide documentation. We typically reimburse these as part of our customer support policy for priority clients.
Very good. We'll prepare a cost breakdown and send it to you. Another point, we'd like assurance that this won't recur. This is not the first time we've seen touchscreen calibration issues.
Absolutely. We are implementing several preventive measures. 1. A full review of the firmware flashing process. 2. A verification checkpoint before packaging. 3. Training refreshers for the final testing team. Additionally, our quality assurance manager will personally oversee the next 2 batches destined for your company.
That's reassuring. Could you also send us a corrective action plan, CAP, in writing?
Certainly. I will share a draft by the end of today. It will include timelines, responsible personnel, and follow-up audits. Would you like us to add a customer-specific inspection protocol to your future shipments?
Yes, please. Something like a double sampling or high-sensitivity test for touchscreen input.
Noted. We'll add an extra layer of testing, specifically for touch sensitivity and firmware validation, for your orders going forward.
That's appreciated. And about the shipping costs, will the replacement batch be sent at our expense?
No, we'll absorb all logistics costs related to the defective units. We consider this a supplier responsibility issue.
Understood. That aligns with our previous agreements. By the way, we've also noticed a slight increase in your unit pricing in the latest quotation. Is that related to component shortages?
Yes, the recent spike in semiconductor prices and rising freight charges have led to a marginal increase. However, for this order and the next, we can honor the previous pricing as a gesture of goodwill.
Thank you. That's helpful. So to summarize, you'll send 35 replacement units within 4 business days. You'll offer a 15% discount on the invoice. You'll reimburse 10 man-hours of technician time. You'll send a formal CAP and implement additional testing. Is that correct?
That's right. I'll confirm all the points in a formal service recovery letter. We'll treat this with the highest priority.
Very well. I appreciate the transparency and swift response. These things happen, it's how you handle them that matters.
Thank you for your understanding. We value your partnership and are committed to restoring your full confidence in our products.
I look forward to seeing the corrective action report and the shipment confirmation. Please keep me updated daily on the progress.
Will do. You'll hear from me tomorrow with the documentation and tracking info. Thank you again for your patience, Mr. Sato.
Thank you, Anna. Speak soon.
Good morning, Jake. Do you have a few minutes? I'd like to go over the quarterly performance metrics for the microcontroller assembly line.
Sure, Mr. Thompson. Let me grab my tablet. Are we focusing on line 3 again?
Yes, line 3 has shown inconsistent throughput over the last quarter. I want to understand what's contributing to the production bottlenecks.
I've been monitoring the KPIs closely. One issue is the soldering process. We've seen a spike in cold solder joints, especially with the new batch of PCBs we started using in April.
Cold solder joints? That's concerning. Have you documented the defect rate?
Yes, I've compiled a defect analysis report. Here's the data: a 3.2% defect rate in April, slightly better in May, 2.7%. It improved after we recalibrated the reflow oven.
That's good initiative. Did the technicians adjust the oven profile according to the new substrate thickness?
Initially, no. We had a mismatch between the thermal profile and the laminate layer. But after consulting the datasheet and cross-verifying with supplier specs, we adjusted the ramp-up rate and peak temperature.
Excellent. That kind of root cause analysis is exactly what we need. Still, let's discuss your team's performance overall. How's the shift team adapting to the new layout?
The layout change created some confusion at first. We rearranged the SMT feeders and implemented a revised Kanban system. It improved line balancing, though operator training still needs reinforcement.
Training is critical, especially with new workflows. How would you assess the team's response time when dealing with a machine fault?
Response time averages about 12 minutes per incident, down from 18 minutes last quarter. We've assigned quick response leaders for each zone to minimize downtime.
Impressive. And what about your individual goals? Let's look at your performance objectives from last quarter.
My goals included improving OEE, overall equipment effectiveness, by at least 5%, reducing downtime by 10%, and submitting a proposal for process automation.
I've reviewed the report. You achieved a 6.3% improvement in OEE, and downtime reduction hit 12%. That's commendable.
Thank you. The automation proposal is almost finalized. I'm working with the IT department on integrating a predictive maintenance module using sensor data from the pick-and-place machines.
Very forward-thinking. What challenges are you facing with implementation?
Mainly data integrity. The sensors were not calibrated consistently across machines. Also, some of the PLCs, programmable logic controllers, don't support real-time communication with the MES, manufacturing execution system.
That's a significant hurdle. Maybe we can escalate that to the systems integration team.
That would help. I also suggest we standardize sensor calibration procedures across all lines.
I agree. Jake, in terms of soft skills, you've demonstrated solid communication with your peers, but I've noticed some tension during shift handovers. Can you tell me more?
Yes, there was a disagreement with the night shift lead regarding incomplete documentation in the production logs. We've since agreed to use a digital checklist with mandatory fields to prevent omissions.
That's a good solution. Let's talk about development areas. Where do you see room for improvement?
I'd like to improve my project management skills, especially for cross-departmental initiatives. Also, I'd appreciate more mentoring on strategic decision-making.
I can arrange a shadowing opportunity with the Continuous Improvement Manager. Also, I'll approve training on Lean Six Sigma Green Belt if you're interested.
That would be great. I've wanted to dig deeper into value stream mapping and root cause analysis.
Perfect. Lastly, let's set objectives for the next quarter. How about focusing on automating quality checks for visual defects?
Yes, maybe using machine vision. I've been exploring open source libraries like OpenCV for this purpose.
That's promising. Please prepare a feasibility study. I'd like to present it at next month's operational review.
Will do. Thanks for the feedback, Mr. Thompson. I appreciate your support.
Keep up the great work, Jake. Let's continue to raise the bar on production quality.